Hey guys, how's it going? So let's explain Krustkals algorithm, very plain and simple for everybody. Here at these ends, we have something called vertices, or what some people call it as well is nodes. So to get from a node to another, we have to take a specific path, and these paths are what we call edges. So these are all possible edges. Now, to explain Krustkals algorithm, really, it's one of the simpler ones. There's just one small thing that I will be pointing out as we go along that throws it a little bit off, but it's mainly not too bad. All right, so what we're going to be starting off with is to find the smallest edge. So the smallest edge from all of this is 1, okay? So we are going to be creating a path from A to B because that is the shortest path. I'm so sorry about that. A to B, okay? So now that we have that, we are going to be looking at the next smallest edge, which would be 2. So we're going to be creating a path from D to C. Now from then on, we're going to again be looking at the next smallest edge, which would be 3, so that creates a path between B and D. Now we're going to look for the next smallest one, but it's 4. Now what we have to think of this as now is that we have created basically a set. We've created a set that's from A to B, from B to D to C. And it doesn't have to be in that order, obviously. But the problem is if we add from A to D, we would be creating, how would you say, you'd be adding that path to itself. So basically to make it even simpler is we just don't want to see any loops, any possible loops. So we don't want anything to connect to itself. So if we were to create a path between A to D, and I do want to keep this simple, that's why I'm throwing in the idea of loops. We just don't want to go from A to B to then from B to D and D to A. So think of this as a loop, even though it's not really a loop, but we just don't want anything like this. So that is the only thing to Krustkals algorithm. We just don't want to create a loop, as you can say. So we're going to be taking that out. Now the next thing is we're going to look at the next smallest edge, and that's 5. But as you guys can see, once I create a path from B to C, it creates a sort of loop as well. So from D, C to B, it creates a loop. So we can't take that one. Now the next possible smallest one is 6. Now if we connect C to E, this does work because it's not a loop. So from D to E, there's no path, so it's not part of the set yet, so we can add it to the set. So now that it's added to the set, we have successfully connected all the vertices, and we have found the shortest path. So that's it for Krustkals algorithm, to put it plain and simple, without having to explain any of the hard math details involving sets and all that. This is our minimal spanning tree, and that's it for this video. If you guys have any questions, if you guys do want something more in depth, you guys can message me, and what's it called? And I will be happy to answer any of your questions. So that's it for this video, guys. Don't forget to subscribe, and see you in the next one.